Awesome. Well, thank you, everybody. Welcome to this week's edition of Water Talks, where we are going to be talking about solving common drainage design challenges. And your host for today, my name is Hunter Sparks. I'm a solutions engineer over here at Autodesk, a part of the Innovyze team. My background is in civil engineering, where I did about 3 years in geotech and 4.5 years of land development, and then have been in the software sales side for about 2.5 years. And really excited to be joined by Midori Patterson today. If you want to give a little intro.
Yeah, my name is Midori Patterson. I'm also a solutions engineer here at Innovyze. Prior to joining Innovyze, I worked in the engineering consulting world for about 5 years, doing mostly stormwater management, some stormwater design, and then mostly stormwater floodplain mapping and modeling for river and models. But yeah, excited to be here and excited to talk with everybody today.
So just a little overview and some housekeeping items. Whether you've been here before or this is your first Water Talks, we always like to remind people that the goal here is to create a community where you guys can come and ask any and all of your questions. We'll provide answers, give advice. Feel free to throw them out at us, and we'll work on answering them throughout the way. And if we don't get to all of them, we'll follow up with you guys afterwards. You can submit your questions in the Q&A box that's at the bottom of your screen. Here's an example of what the box will look like, and a common question we typically get, so we'll just answer it off the top. Will this session be recorded? Yes, it will in fact be recorded, and typically we are able to distribute the recordings to people. We highlight the chat box just to remind people, don't put your questions in that chat box. We're just going to be monitoring the Q&A to look for those questions. And just a reminder to some people, we've moved Water Talks now to every other week as opposed to every week, but we're still Tuesdays at 12 Eastern. And get registered for some upcoming Water Talks on the 26th. We're going to be looking at the advantages of using your GIS data within your model. And that's going to be focused on InfoWater Pro, as well as looking at how you can monitor your water KPIs with Info360 Insight. And so just a quick rundown of the agenda today. We're going to be once again talking about solving common drainage design challenges. We're going to start with a general InfoDrainage update, and then we're going to have 5 common challenges of drainage design, and then we're going to move into how InfoDrainage can help with these challenges, and then we will leave time for Q&A at the end of the session. So with that brief introduction, Midori, I'll go ahead and pass it over to you.
Thank you, Hunter. So some InfoDrainage updates with the global launch, with Autodesk global launch of Innovyze products that happened a few months ago. InfoDrainage is now available on Autodesk subscription. So it is available in 2 different tiers, the standard tier and the ultimate tier. In the standard tier, you still get a vast majority of the InfoDrainage capabilities. You get the ability to lay out conceptual and detailed drainage designs, the ability to import and export CAD data, GIS, and text. All of the sizing calculators are still within that standard package, and also the 2D analysis of drainage layout, or the deluge tool, which we'll talk about a little later. You still get all of those with the standard package. In the ultimate tier, you get the addition of these two additional features, but they're both pretty powerful. So you get the full capability of the round tripping between InfoDrainage and Civil 3D with the ribbon, the InfoDrainage ribbon within Civil 3D. And you also get the ability to perform a combined 1D and 2D analysis to check for exceedance flow. So if you have a stormwater control structure that's overflowing, the 2D aspect combined with that 1D aspect of the calculations allows you to track where those overland flows are going to go. So those are the major differences there. And with those updates, we'll kind of dive right into these 5 common challenges of drainage design. And so if you're In my experience, in Hunter's experience, in a lot of the experiences of the customers that we work with, drainage design gets a pretty bad rap. It is something that is, typically occurs kind of at the end of the design process. It's occurring when budget and timeline is already super tight. And it's kind of just something you need to get out the door. And while I personally believe that drainage design can be cool and interesting for a lot, there's certainly everyday challenges and major pain points. And so some of the most common are, firstly, just recreating work and manual data input can be time consuming and can open your design up to error. Secondly, you need to be able to track different aspects of design and different design iterations as you move through your process. Third, green infrastructure increases design complexity and is becoming more of an industry focus. Fourth, it can be difficult to express information to non-technical stakeholders in that permitting process. And lastly, you must demonstrate compliance to local standards. And so if we could just make some of these pain points a little easier, I think drainage design wouldn't get such a bad rap. And that's kind of why I enjoy talking about InfoDrainage, is because it solves some of these drainage design problems so you can spend less time doing those tedious and laborious tasks and more time designing, more time optimizing. And even if you don't ever find InfoDrainage or drainage design interesting, obviously just making the process more efficient is always appreciated. So now we're going to dive into those 5 issues a little more and pop into the software to show how InfoDrainage can help. So starting with that first one of recreating work and manual data input, this is something that kind of happens with all aspects of design that is iterative. Recreating work is inefficient. Transferring design data between separate products takes time, and kind of that manual data entry, frankly, kills brain cells that can be better used doing something creative or solving more interesting problems. And so InfoDrainage's integration with AutoCAD Civil 3D automates a lot of those processes and kind of helps you avoid those manual rework. Additionally, manual input is error prone. I think as engineers, we all probably have detail oriented on our resumes, but if you're at the end of a 60-hour work week, just trying to get a drainage design out the door, those ones can start to look like 7s really quick as you're changing, as you're copying over pipe size from an Excel spreadsheet or another package to Civil 3D. So just by having that data from Civil 3D, following those pipes and structures into InfoDrainage and vice versa, helps cut out that risk for human error. And having too many tools, a lot of drainage design software can be, or historically has been kind of broken up into disparate projects. So you might have one tool to calculate your pipe sizes, one tool to calculate your pond size, and then another tool to get everything into actual construction drawings. And so kind of having this single platform for sizing those pipes and BMPs helps streamline your process, helps you deliver your projects reliably, efficiently, and as part of a comprehensive solution. So I'm going to hop into the software really quick. Start sharing my screen again. All right. And so you can start your design within Civil 3D and use the pipe networks and surfaces that are already in there to help lay out your drainage design. The export wizard will kind of guide you through that process. And then that export can be opened directly within InfoDrainage. And you can see all of the data that had been transferred over from your Civil 3D drawing into InfoDrainage using the various graphical and tabular views that are in there. So you can see your lengths, diameters, roughness, all that sort of data. And diving into that export process a little further, you can see that parts mapping is built into that process. And it means that those objects are maintained with their 3D representation, which is required for BIM compliance. And you can see the detail with those real world parts contained within the Civil 3D parts list, mapped manually as we're showing here, but then that can be saved to a configuration file so that, you know, as those iterations occur and you are kind of taking things in and out of Civil 3D and InfoDrainage, you can apply those configurations so you don't have to do that every time. And those parts will be mapped in the same way as you continue to iterate on your design and continue to round trip that data. And then once you've exported to InfoDrainage and done your design calcs there and want to bring it back into Civil 3D, that import process is pretty similar. Once we kind of, again, you walk through that parts list, you can open those configuration files, and the round tripping of that data ensures that the network is updated with not only your pipes and manholes, but your stormwater control structures that are true to site as represented in InfoDrainage. And as you can see, as we kind of look through this design, that those stormwater control structures came in as accurately as they were in InfoDrainage in Civil 3D. So we've maintained those correct connections. We have these surface feature lines that we can incorporate into our surfaces and grading plans, and all the elevations, all that 3D representation has been carried over as well. And if you do have additional changes to make in Civil 3D, such as like moving a manhole as shown here, or it could be something like changing the levels in a stormwater control structure, you can just repeat that export process and continue iterating your design in InfoDrainage. And so I will move on to our second most common drainage design pain point. So I started sharing my screen again. And this second point is just the need to track different aspects of designs and different designs as you're going through that iterative process. And obviously, there's always going to be iterations in any sort of design process, and there's certain techniques and kind of design hygiene practices that you can follow to stay organized, but you can, just by having a platform where you can keep everything in one place, kind of gets rid of that need to have, for instance, an Excel spreadsheet that's tracking the different file paths. Or, I remember when I was doing stormwater design, having like a folder full of file paths with, or design files with the diameter in the file path and trying to be as descriptive as possible. So having something where I could just keep all of my iterations in one place would have been saved me a lot of headache in tracking those different iterations down. And so, yeah, I kind of just mentioned the iterative designs are hard to track. So keeping those things in one file, having a phase management tool like we do in InfoDrainage to track those iterations. And then, of course, it's also difficult to kind of keep track of those design outputs. Building like a custom comparison spreadsheet can be time consuming, and InfoDrainage has these reporting tools that make it easy to compare those phases as you're going through the process, so you can easily compare and optimize your design and compare alternatives. So if I jump into InfoDrainage really quick. I have this project set up. I have this storm network built out and these different stormwater control structures in here. And what I want to highlight as far as keeping track of different design iterations is these different phases that I have built into this project. So I have an existing conditions phase, which is basically just a one giant inflow area. I have a pipe sizing phase where I could start to do a lot of my iterations using tools like the network design wizards to hone in on the most efficient pipe sizes. I have just a basic stormwater network where I just have a traditional detention pond, and then I can also have LID design alternatives where I have like a swale and some porous paving in here. When you run the model, you have the opportunity to run all of these different phases at once, or you can toggle them on and off. And it's also super easy to duplicate these phases so that you can start to add additional stormwater control structures. You can start to kind of play with some of the inputs, again, change those pipe sizes, change the different outlet controls, and optimize your design. And then in order to compare those, if I had run this, you can pull up the comparison report. I exported this PDF from that comparison report just to kind of show you what it looks like. And you can, again, easily compare those inflows, runoff reduction rates between your different phases. And you don't have to export it to a PDF. You can just pull it up within the product as you're going through it. So you can kind of get those real-time updates as you're working through your design. And additionally, you can, in addition to viewing it in that tabular format, you can view it in something like this, like a graphical format where I have the different phases, the hydrographs from those different phases plotted on the same chart, so you can easily kind of compare the performance of your different phases. And so I'll start presenting again. The third drainage design challenge is that of green infrastructure. And when I was first starting in the stormwater industry, I came in starry-eyed and excited about these different rain gardens and different looking at these cool and interesting stormwater design features, trying to convince my PM to incorporate permeable pavement into our designs. But at the end of the day, my Excel calculations were not quite convincing enough. And while I think of green infrastructure as kind of an opportunity, there's obviously a lot of pain points. And one of them is just that green infrastructure design information is limited. It's definitely kind of a new emphasis in the industry, and there's not that much information out there on how to incorporate it into a design. But InfoDrainage has green infrastructure stormwater control templates built in, ready for you to just drag and drop onto your site and add to your stormwater management plan. Additionally, software isn't quite set up for green infrastructure, so a lot of CAD and analysis software products don't or haven't had the sizing calculations for those green infrastructure modules. And within InfoDrainage, not only are there some green infrastructure templates built into it, but you have the opportunity to build out your own object templates if you're in a jurisdiction that has guidelines or has design criteria for green infrastructure. And I'll kind of show that in the product in just a second. And then lastly, incorporating green infrastructure increases design complexity. Obviously, having a detention pond off to the side of your site is really simple. You can store a lot of volume that way, and you're not going to get that same volume storage with just one small curb bump out bioretention cell. And so a lot of times, in order to kind of achieve those same volume storages, you need to have these green infrastructure, you need to have multiple aspects of these green infrastructure modules spread out throughout your site, and a lot of times kind of working in series. And InfoDrainage solves the St. Venant 1D shallow water equations to calculate the discharge in each physical connection. But basically what that means for green infrastructure is that you can represent backwater effects. So you can have, you can model these treatment trains of green infrastructure, and you can link them up and link them up to achieve those lower discharges and avoid just a basic pipe to pond solution. And of course, if you have a different, Excel spreadsheet that's calculating the storage capacity of each separate green infrastructure, that's going to get pretty complicated in a kind of traditional stormwater approach. So I'll jump back into my model here. And kind of what I want to highlight. So like I mentioned, InfoDrainage has these built-in green infrastructure controls that you can drag and drop. So we had those loaded in this LID design. But one thing I wanted to highlight was just the ability to build out these custom green infrastructure modules. So I'm based in Denver, Colorado, and the city and county of Denver has these ultra urban green infrastructure guidelines, where basically it's just a criteria manual for green infrastructure BMPs. They provide these design notes, kind of min max criteria for things like width, longitudinal slope, depth, water quality, the water quality capture volume, freeboard, depth of the bioretention. And so something that could save a lot of time is just building out these modules within an object template, so you can have these custom criteria that you can just drag and drop. And I have these loaded or saved into this template. So if I just loaded this object template file, I have these modules built in, things like the porous paving, things like these bioretention cells. And so that can speed up the process and can kind of help you incorporate green infrastructure, which is something that a lot of clients are asking for, and but do so in a way that will still get approved by your local permitting agency. And with that, I'm going to pass it over to Hunter to finish out the last two drainage design challenges. So I'll stop sharing and let Hunter take over from here.
Great, thank you, Midori. Always the most stressful part of any presentation, trying to switch who is sharing their screen. And can you just let me know if you're seeing my presentation?
Yep.
Perfect. Excellent. Well, so the next challenge that we're going to talk about that we commonly run into is it can be difficult to express the information to non-technical stakeholders, or sometimes even getting up and running in a new software. Trying to learn a new software, it's really never easy. You open it up, you're not exactly sure where to start. This happens in every program, but it seems to be especially true in engineering software. There's a ton of different steps, and not all of them are easy to follow. And then when you're finished working on your design, you pass it off to your reviewer or someone that's QA or QCing. It's often filled with a ton of questions. This is because whether you printed out the reports or you're sending along your design, it's not always easy to spot design flaws, where you might run into some issues, or where the system might not be operating how you would expect. And InfoDrainage is different than a lot of other softwares. How it's laid out, it's very intuitive to pick up. So when you march across the ribbon at the top of the page, you're able to go from start to finish for a drainage design. And once the analysis is done, you can actually run a simulation of the rainfall coming through your system. And in an animated nature, it's going to show you where that HCl is in your pipes, in your stormwater control structures. And it's even going to give you notifications where you have surcharging, flooding, overtopping over your stormwater control sections. And then we also have something called the deluge tool. And this is another example of how the purpose-built tools within InfoDrainage can assist with not only setting up a new sites, but trying to point out where water is naturally trying to shed and maybe trying to keep those low points for a more efficient design, keeping those cut fill numbers down. But also you can use it as a QA/QC tool where it's going to simulate dropping water on your site, and you have the ability to see where you have low points and make sure that you have inlets there. So this simple tool is really beneficial for at the beginning of designs or being able to QA/QC to make sure you're able to get water off your site efficiently. And so with this, all of these can come together to allow you to express and review the design with a far range of technical skills. And so we're going to go ahead and jump into the software and just talk through some of these tools. Perfect. So when you open up InfoDrainage, as you can see how it's laid out, you have a window where it shows your plan and a tree view and a toolbox. It's a very simple view. All your tools, and options are visible. And what I was mentioning in the PowerPoint is up here at the top in the ribbon. As you can see, if you start with import and march all the way across the top, you can get to export and you can really set up your design, do preliminary sizing, add anywhere that you might need to, overtop a pond, add any stormwater control structures, run your analysis, pull out your results, and then export it. So really step by step, it walks you and guides you through the design process in a very intuitive, very easy to understand fashion. And so that tool for getting started, sometimes you start on a site and you just want to know where water is going, where that information is to try and match where the stormwater is going. So by running this deluge tool, that's where you're choosing just a traditional Manning's M, giving the minimum element ID as well as the depth and the analysis time. And when you run this and turn this on, as you can see, we'll go ahead and throw on flow directions, the legend as well. As you can see, a simple analysis, really without a ton of, oops, didn't mean to press on that. But one of the other nice things is if you do make a mistake, it does have a very simple back tool. So you're really never too far away from the last iteration of what you did. But as you can see with this deluge tool, with very simple, very easy steps, not really a ton of engineering involved, I found that I have, a ridge typically running at the southern side. And as we can see, pond is traditionally trying to move to the north, and you have some ponding and low points. So if you have the ability to match those low points and trying to use some of that design, it can be more efficient, spending less money, and just kicking off your design is a lot easier and more efficient. So after you've run your initial design, let's say, and one of the tools that Midori pointed out that we'll just reiterate here is that phase management. As you can see, we have an existing developed and a couple designs. So let's say with this developed, it's our initial design. We took a stab at it, just trying to see how our pipes are sized. But how do we know if they are properly sized? If I'm just looking at it here, it's not, super easy to tell. I could dive into these results and start, opening different reports and trying to compare those. But what's really nice is if someone were to open this, all they would need to do is open one of these profiles. And as we can see, the red line is going to tell us where the water levels in the pipes or in the stormwater control structures are. And by just coming down here, I have the ability to choose different storm types. So as we can see, we'll look at the 5-year, it's starting to get close to the top. If we get to the 100-year, it's starting to overtop everything, surcharge, even have some flooding at the manholes. And so you have the ability to look at this side by side, knowing what you're looking at, but also you have the ability to run through that animation that we discussed earlier. And what you're going to start seeing is as that water starts getting higher and higher and starts overtopping the rain garden, overtopping, getting to the freeboard of the pond, maybe getting to the top of your manholes, it is going to start throwing these notifications at you. And so you don't need to dive anywhere else into this software. Just by playing that animation, someone that maybe doesn't have the most technical background in drainage design can, in their eyes, instantly go to that and say, hey, you know, there's something in this design we need to take another look at. We need to make sure that we are resizing this to make sure that it's sized appropriately. And, you know, we didn't run through, have to look at complex reports. You didn't have to pull up any hydrographs in order for you to realize that this needs, you know, a little bit of tweaking in order to fix this design. So even people that don't have that super technical background can pull that information out of the software. And before I hop back into the PowerPoint, we talked about using that deluge tool not only for setting up your site, but also as a QA/QC method. And so we looked at an existing surface previously. As you can see in this proposed surface, we are starting to have some ponding. And let's go ahead and turn on the legend so we can see, you know, we're starting to actually get some ponding in the southwestern corner of our site where we don't have, you know, necessarily have an inlet. So that can cue someone right away without having to go run calculations, look at the surface in Civil 3D and instantly say, hey, maybe we need to add an inlet here. You know, very easy, very quickly able to make that assessment. And that deluge tool is really, really effective for QA and QCing that design in a very simple fashion. And so we'll switch back to the PowerPoint. And finally, the last challenge we're going to touch on today, you know, there's really a lot of goals of a project. We want to design it efficiently. We want to save the customer money, finish it on budget, on time. But one task that is extremely time consuming and very rigorous is demonstrating compliance to local standards. Oftentimes it can be difficult to track these down and make sure that you're checking those boxes for approval. From my experience, Midori and I have actually talked about this a lot, making sure you're having those compliance, putting together the drainage reports, and all those appendices can be very time consuming, bouncing between different softwares, trying to pull that information in. And within InfoDrainage, you have the ability on the initial side of the design, use what's called the design wizard to size pipes, set slopes, size your manholes based on local standards, so that you know in the beginning you have your design is set up to meet those slope and size requirements. You also have what's called the engineering audit tool, which allows you to look at different aspects of your design. After you've run your analysis, you can set max, min, or a range of values to ensure that you're falling within the guidelines set by local utilities. A lot of times utilities are going to let you know what the minor event is, what the major event is, and where the HGL of those events need to fall within the pipe. And you have the ability to look at those profiles like we just saw, seeing where they're overtopping, but also seeing where they're staying in the pipe. And you can actually pull out those profiles as images, PDFs, or you can actually export them as CAD files and open them up in Civil 3D. And then you also have the easy report generation. So engineers are able to decrease the time it takes to show compliance and generate the reports to submit to the local municipalities. And so we will go ahead and switch over one last time to InfoDrainage. So for example, looking at the network design wizard is going to be in this preliminary sizing tool. So we're going to open up the wizard, choose one of our flow paths, and we're just going to march through and show what this would look like. As we can see, we can choose which which storm we're using and which return period we're going to base this on. And then at the next screen, there are a couple different options that you can use to try and set that information. So you can set up a default pipe size library. And these are just default values that we have pulled in. But let's say you work in a jurisdiction a lot, and you just want to have those minimum and maximum slopes tied to the diameter of the pipes handy so that you're not having to recreate work. Well, you have the ability to save these as pipe sizes and the slopes tied to them. And we're going to go ahead and pull in what would be the Colorado Springs pipe sizing. And so as you can see, Colorado Springs tells you if you're 30 inches or below, you have to have at least 0.5%. If you're 36 or above, you have to have at least 0.3%. So as you can see, by just bringing in that information, we are able to do, if we wanted to do a full design based on those, where it's going to set those pipe slopes as the minimum and maximums. And then you can also set targets that you're comparing it against, as well as check the velocity. And if we were to march through this, as we can see, it is going to highlight in yellow the changes that it would make to the design based on the information that you put in the design wizard. So just right off the bat, this is getting you your pipes, the sizes, and the slopes tied to the values that are set forth by the municipality. And so once you've done, all of your design, you've gone through maybe a couple iterations with the maybe with the utility, or maybe this is the first time you're going with the utility with a more detailed design. You want to make sure that what you're submitting is hopefully going to be approved as quickly as possible. I would love to say that, that everyone that I submitted got accepted on the first try, but I don't think that's possible. I've learned that that's just not possible to do. But with InfoDrainage, you have the ability to check some of the information to make sure that you are creating a design that can be accepted by the municipalities. So we're going to open that audit report that we discussed earlier. And as we can see, you can check things like infill summary, the outfall details, pipe, if you have minimum and maximum diameters set forth, manhole sizes, just a lot of really good information to just mark down and check through and check that box for the municipalities. And so what you can do is you can set ranges. We're going to look at cover depth and we're going to look at velocity. And once again, pulling the information straight from the Colorado Springs Utility Stormwater Design Guide, the cover depth, minimum of 1, maximum of 15, and then the velocity between 3 and 18. And if we perform the audit, we are going to see that for the developed and the completed, being able to compare both, we can see that we don't, all of our items pass. As we can see, we get check marks. If either of these would have been out of range or out of compliance, we would have gotten an X, and then a list of pipes, or if you're sizing manholes, a list of manholes that are out of compliance. So just by running this audit report, it's spitting out to you, hey, you need to go look at these things very quickly, very efficiently. You can also provide this as an appendix to your drainage report. And so another thing that utilities will dictate, as discussed in the PowerPoint, is how the minor and major storms need to be contained in the pipe. A quick check and way to present this is to look at the profile view with those HGL lines. And we're gonna open up the flow path again. And as we can see, we can switch between the different storms, very similar to the previous. Once again, using the Colorado Springs utilities, you have to be able to keep the 5-year storm within the pipe, and the 100-year storm can be surcharged, but it has to be at least a foot below the finished surface. So as we can see, our 5-foot HDL line is staying within all of our pipes. And by switching to the 100-year, we can see that even though it's surcharging, we're staying a foot below the surface. So this is just another example of how you can pull this information, make sure you are hitting those regulations. And then a lot of times you need to provide this in drainage reports, or maybe you want to use the CAD data in order to look at it later, in order to aid in your Civil 3D pipe profiles, and you have the ability to print the PDF, save it as an image, or export it to CAD and open it directly in AutoCAD Civil 3D in that environment. And so last but not least, we have a lot of really good reporting options, allowing you to look at the results in different fashions, whether you're looking at, all of your different pipes and the maximum flow and just getting an overview of that information. But one of the ones that I really wish I had when I was doing these designs was this comparison report. And this kind of touches back on something Midori also was talking about, being able to compare multiple different phases in one report, being able to make sure that your design maybe is the most efficient, or just making sure that the design that you have, the max outflow is less than in your proposed situation versus the existing situations, which a lot of utilities will be checking against. So if we come to this comparison report, you can go down, choose the different phases that you want to look at, as well as choose the different storms that are required, because each municipality will ask you to look at different storms. You also have different tabular results and graph results. And then we can go ahead and generate a preview. And this is just going to take a second to generate. And in that little bit of time, as you can see, just marching down, we have the existing, our developed, which we knew was undersized. That was just that preliminary development, does not meet the criteria. But when we get to our completed design, our maximum outflow is less than in the existing than the proposed. So you're creating these hydrographs, you're creating these graphical representations. You can customize the header with the project, the date, and company logo if you wish. And all of this information is readily available for you to put in your reports. And then finally, if you really want to have a extremely comprehensive report, an overview of everything, not just the comparison report. If you go to print, you can choose your phases, different events that you want to look at, whether it's a critical storm, select storms. If you want to do, choosing different storms, and then you can look at not just your comparison results, but your connection results, stormwater control results, connections, manholes, outfalls, all of that information, and really create a comprehensive report that gives you an overview of a little bit of everything. So you can do a lot within InfoDrainage to help generate those reports and really start making sure that you're checking those boxes that they require to see. And so with that, I think we've marched through everything within the software and the PowerPoint. Thank you everyone for attending. Thank you, for being here. You can go ahead and throw your questions. I see we have some in the Q&A, and we can go ahead and march through those.
Yep, sounds good. Thanks again, Hunter, for that. I think that, yeah, love seeing the audit reports for those the Colorado Springs requirements. Yeah. Again, something I just wish I would have had. But yeah, marching through these questions in our Q&A, we have a question that asks, does it do dual drainage systems, minor and major? And I'm not 100% sure what this question is asking. Hunter, do you have an idea?
Yeah, if Sandra, if you want to send a little bit more information on what you mean, just so we can make sure we're answering it appropriately, or shoot us an email afterwards. We'd be more than happy to answer that. The next one we have a multi-part question. What is the difference between SSA and InfoDrainage? Does InfoDrainage work inside of Autodesk like SSA? What is the Autodesk offering them? We have both. Is there any benefit if we already have Civil 3D and want to have InfoDrainage, and then is InfoDrainage and InfWorks ICM interchangeable, and then is XPSwim model compatible for drainage software. So we'll take each of those one by one. Midori, do you want to go ahead and kick it off, and then I'll just add any detail where needed?
Sure. Yeah. So this first question, we get this a lot. Differences between SSA and InfoDrainage. And I guess kind of an easy answer is just that InfoDrainage is a little more robust of a tool and is just more of a graphical tool than SSA is. SSA is kind of more of just an analysis tool rather than a design tool. When you're exporting to SSA from Civil 3D, it will simplify everything down to kind of links and nodes, so you don't really get, whereas if you're taking things from InfoDrainage to Civil 3D, it doesn't simplify that down to a node. You'll still get your stormwater control structure. If you have a pond, it'll actually come in as like a feature line. And so it basically is more robust in that way. And then also, just kind of the interoperability between Civil 3D and SSA, or between Civil 3D and InfoDrainage, is a little more streamlined. Again, kind of SSA isn't quite, it's not as much of a design tool. It can involve numerous cycles of interpreting those results, updating them in Civil 3D, regrading, exporting back to SSA, and then assessing everything again, where kind of the entire drainage design process can be done within InfoDrainage. And then the question about if InfoDrainage works inside of Autodesk like SSA or Civil 3D. So kind of what I mentioned with the InfoDrainage, the ultimate tier, you have the import export ribbon within Civil 3D, so you can access it directly from there. It's not a fully dynamic relationship at this point, so it is still taking something from Civil 3D, exporting it to InfoDrainage, and then bringing it back into Civil 3D. But the parts mapping manager feature gets you most of the way there and really does minimize a lot of that rework, and that process becomes relatively painless. So that's kind of the extent of how InfoDrainage works within Civil 3D.
And just to add a little on that about the parts mapping, I know you and I have talked to a couple different people that are looking at this software, have this software, and that is the parts mapping side is really something they find really beneficial and kind of taking it to the next level. A lot of people do have those custom parts mapping, so being able to have that saved and brought over is, it is something that seems to be very beneficial. So just wanted to add that.
Yeah. And then, this next question about why, or maybe, yes, Autodesk is offering both, or like it does have Civil 3D and then also offers InfoDrainage. The decision behind that is probably way above my pay grade. But InfoDrainage, I guess to answer kind of the next question, InfoDrainage is a separate subscription than Civil 3D. It obviously plays well with it, but that would be a different license that you would need to buy. But you can purchase it now after global launch through the same Autodesk subscription process that you would download, or that you would buy other Autodesk products from.
Just to add a little bit on that about were you on the any benefits of having both? Is that the one? Yeah. I mean, I think really the benefits of having both is being able to move between two and the two of them. And also a lot of people are using HydroFlow, HydroCAD, SSA, Excel spreadsheets, really a combination of a lot of different things to do a full kind of Spectre drainage design. And another thing Midori touched on is that green infrastructure portion that is built into InfoDrainage. So I think being able to do that start to finish, designing, the pipes, the stormwater controls, concentration on green infrastructure, but also being able to use your CAD data would be a benefit if you already have Civil 3D of moving to InfoDrainage for that.
Yeah, and then the next question is InfoDrainage and InfoWorks ICM interchangeable? There is a routine within InfoWorks ICM to load a pipe network from InfoDrainage. It would just import kind of the geometric properties of that pipe network. And doesn't necessarily like save the InfoDrainage model results, but basically adds the InfoDrainage pipe network to your InfoWorks ICM model that you can then run in ICM. And then I think as far as there's not like a routine in InfoDrainage to load an ICM model, but they're kind of meant for different purposes, where InfoDrainage is more that site specific scale, where InfoWorks ICM is kind of more entire watershed, that entire watershed size of things. So bringing in an InfoWorks ICM model into InfoDrainage wouldn't be advisable, or wouldn't be super advisable. And then is XPSwim model compatible for InfoDrainage software? So InfoDrainage software does use the XPSwim engine in the background. However, there is not a direct import routine for loading an XPSwim model to InfoDrainage or exporting an XPSwim model from InfoDrainage at this point, but it is a comment that we get a lot. So yeah, that is just a common question as well. And then moving on to the next question, can we create custom IDF curves, or does the software have options for Canadian rainfall calculations in soil parameters for Canada? The first part, yes, you can create custom IDF curves. And as far as the soil parameters go, I think these infiltration methods are something that are being expanded upon. Hunter, do you know anything else about the soil parameters for Canada specifically?
I don't believe for Canada specifically. I know there are ways to, use and edit the soil parameters within InfoDrainage, but I don't think inside of it has the soil parameters for Canada. But
okay,
yeah.
And then the next question that we have is InfoDrainage capable for analyzing watersheds or subcatchments? And I'm not sure, Thierry, maybe if you want to provide a little more what you're looking for analyzing watersheds or subcatchments. And there's definitely, like, within the inflow areas in InfoDrainage, there's different parameters that you can add about kind of the like imperviousness levels. But as far as analyzing those subcatchments, there's also not like ways to automate those subcatchment delineations, if that's what you're asking for. And that is still something that is done, or we recommend doing manually, or to do in Civil 3D with your grading plan or with your surface, and then importing into InfoDrainage. But let me know if that didn't answer your question. And then also, is InfoDrainage capable to analyze open channel or river capacity analyses? I don't think so. There's swale stormwater control features within InfoDrainage that can kind of get you part of the way there. But as far as, like, a similar thing to like HEC-RAS, it doesn't do that kind of analysis. Hunter, is there anything that you want to add there?
No, that's kind of what I was gonna add. You can size some, some channels, with the slope because you can do it for a like an overflow for a pipe would technically be a channel. I think once you're getting into river capacity analysis, I think that is something where you're going to want to move more towards the ICM side. InfoDrainage is still designed more for that site specific design. And once you get into that capacity analysis, I think that's kind of a move over to ICM would be my thought.
Yeah.
And it looks like we did get a follow-up information on dual drainage systems, being able to do surface and pipe. Can you add street flow gutter as a conveyance channel sitting on top of a pipe network? And you can do that. You can size gutters and that information in InfoDrainage as well as the pipes.
Yeah, and again, kind of some of that overland flow with the ultimate tier of InfoDrainage, you can do those combined, like 1D, 2D analyses to kind of, I'm not sure if you can really like get into sizing like channels for that overland flow, but you can, if you have a surface, you can see where it would go based on that surface. And then, yeah. And another question, going down in order here, is there a way to update XPSwim inverts and pipe sizes from a pipe network in CAD like was shown for InfoDrainage after it was already imported once, but with preserving everything like those landings values and associated drainage areas, curve numbers, etc. And then a follow-up question, is InfoDrainage going to replace XPSwim eventually? I know I can't speak to, XPSwim is kind of one of our older products. I can't speak to its capabilities in CAD. I don't think so. InfoDrainage is kind of unique in its interoperability with Civil 3D. It's definitely the most integrated with Civil 3D out of all of our products. I guess to kind of talk about the follow-up question, InfoDrainage and XPSwim are, XPSwim again isn't really geared towards being a design tool. I know that a lot of our customers do use it for design. I don't necessarily think InfoDrainage would be the product to replace XPSwim. I think InfoWorks ICM would probably fill that a little more. But it's XPSwim isn't going anywhere for the time being. Hunter, is there anything you want to add to that?
No, I think you covered it. I think you covered it really well. Difference between kind of and these words are sometimes interchangeable, but an analysis tool versus a design tool, because you can also do a little bit of both on either side. But I think that's kind of two different ways to look at it. But I don't think InfoDrainage would be replacing XPSwim at this time. That's all we know, at least right now.
Yeah. And we are at the top of the hour here, and we do have a lot more questions. I think there were also some questions in the chat. I think we will have to wrap here, but we will follow up with all of these questions in an email. Again, our emails are added on this slide here if you want to reach out to us. And also there's Hunter, do you want to wrap up I'm kind of new to these Zoom webinars, but they basically get a questionnaire at the end, right? If they want us to indicate if they want us to reach out to them.
Yep. They'll get a poll question.
A poll question. So yeah, but thank you everybody for attending. Thank you for the engagement and for all these great questions. Yeah. We will definitely follow up on these. And again, thank you so much for joining.
Thanks everybody. Thank you, Midori.
Thanks, Hunter. Bye.